Okay, now we go to module 7, which is sorting. What's sorting? Sorting in this module is interpreted as a sorting algorithm. Many methods can be used in sorting data. Sorting can be done by ascending or sorting from the small value to the large value, and sending or sorting from the large value to small value. Okay, method sorting array. There are 4 methods will be discussed. First, counting sort. Second, selection sort. Third, insertion sort. And fourth, bubble sort. Will be explained in more detail later.
Hello everyone, let me introduce myself. My name is Farhan Octavian, with the code the assistant is AIN. Here, I'm going to explain a working principle of the counting sort. First, create a new array with a range as many the minimum value to maximum value. Then, the content of the odd array will be moved to the new array based on the frequency of the data in the odd array. Then, the content of the new array will move back to the old array in order. For example, we have 5 arrays with content of 0, 3, 2, 6, and 5. Then, we create a new array based on the minimum value to the maximum value. We know that the minimum value is 0 and the maximum is 6. So, we create a new array from 0 to 6. Then, the content of the odd array will be moved to the new array based on the frequency of the old array. That's why the new array will be filled with data from the old array. Then, the data from the new array will be moved back to the old array in sequence. Now, from previously unsorted array value with counting sort, it becomes sorted. That's the working principle of counting sort. Thank you, everyone.
Hi guys, my name is Pradipta Ramadan and my assistant code is DPR. So I will show you about counting sort. Like we know, counting sort is we must make new array for the sorting, and I will show you the algorithm. So in this algorithm, we use two array, and that's a data array for the main array, and second is temp array for the function is for the temporary array. So I will show you and explain about this algorithm. In line 1, we have include studio.h. So basically this is for the library. And on line 4 and line 5, this is for lots of data. So how many data we want to input. And then on line 6, that's integer data. This is for the size the data array. And the line 7 and line 19, this is for the find the value of max and min. And in line 21 and line 22, we have empty the array temp. So like I said before, array temp is a function for temporary. And in line 24 and 25, this is for first counting sort process. This counting the data frequency. The second counting sort process is build the main array on line 27 and line 32. And on line 35, and 36. This is for the display the sorting results. Now I will show you the output of this algorithm. So let's say we have five data. We want to sort. So 5, 7, 1, 3, and 2. And then the data has been sorted from the largest to smallest.
Hello everyone, I am Agus Mutafarid with the GUS Assistant Code. Here I will explain about this seventh module, namely sorting in the section sort section. Next section sorts. This is how section sorts to work. Look for extreme, maximum or minimum values in array A. For example, array A is the array you want to sort. And exchange 3 with the first index. Then isolate the first index, B. Then determine the next extreme value and exchange with the second index. Then isolate the second index, C. Repeat these steps until the last delta. Here is an example of the section sort method in ascending order. Here, we have array A with initial value of 3, 7, 2, 1, 6, and 5. Then, from the initial value or array A, we look for the minimum value from index 0 to 5. We get the minimum value, which is 1. Then, we exchange or isolate it with a value of 0 or index 1. After that, we repeat this step so that we get the final value or value that has been sorted using the section sort method in ascending order, namely 1, 2, 3, 5, 6, and 7. Okay, next. For more details, we can see the section sort method in this video. We start with the same initial value as before, namely 3, 7, 2, 1, 6, and 5. Okay, wait. Nah, the first steps is to find the minimum value from index 0 to 5. We get a temporary minimum value, which is 3. Then we compare it with the next index. Is 7 similar than 3? If not, we continue to compare it with the next index, namely 2. Is 2 similar than 3? If yes, then 2 is the new minimum value. Continue if we have got a new minimum value, namely 1. Then we change it to index 0, which is the value of 3. Then we repeat this step until the end, so that the result after sorting is are 1, 2, 3, 5, 6, and 7. Okay, let's start. Okay, next to see a program. Okay, continue to the coding example. Here, I am using the section source code example in ascending order. The first we can see in line 7 is that we can enter the amount of data to be sorted. Then you can feed the minimum value or the maximum value depending on the sort method. Can be ascending or descending. Okay, then we continue to row line 10 to line 10. The algorithm looks for the minimum value in the data and then expands to index 0. Now this process repeat until the data is solved. The last one is len 22 to 24. Len which function to display the result of the data that has been solved using the selection sort method in ascending order. Okay, then we try to run the program. A6. Okay. Now we can see the result of the data are sorted from the smallest to the started or ascending. Okay, maybe that's all I can say. Thank you.
Hi guys, I'm Natasha Vidura Barus with an FP assistant code. Now, we will learn about one of the sorting method, namely insertion sort. Okay, how does it work? Next. Okay, the working principles of insertion sort is to sort the numbers that have been read, and the next will repeatedly insert numbers in an unread array to the left of the sort array. If you notice, almost similar to the bubble sort method, which compare data with the data next to it. But in insertion sort, the comparison is automatically proven correct in the condition in front of it directly in its stage, or conditions are checked in the front. Okay, let's see the illustration. The data at index 1 is compared to the gray area. Because 3 is less value than 5, or 5 is bigger than 3, we need to insert a second data in the gray area. Okay. So the gray portion remains relative order. And let's do it to finish. B. Slide the data on the gray part. C. Insert the data that has been issued to the right position. D. Now the first two data are sorted relatively. Then insert the data in the gray section in the same ways as section A, B, C. And repeat the process until the last data. Okay, let's see the illustration. The keyword is not only check sideways, but to the front. Okay. The keyword is not only sideways, not only check sideways, but to the front. Okay. Let's see. Okay. Okay, finish. Now let's see in the form of programming. Include stdio.h. This is a preprocessor directive to include the standard input-output library. Standard input-output library, which is required for using input and output function. Okay, next, the void main. This is a main function of the programs. And integer numbers, I, G, X, temp. It is declare variable including an array numbers to store the data. It is array number to store the data. ing loop control variables, X to store the numbers of data, and a temporary variable or temp variable for sweeping value. Okay. Printf numbers of data, scanf, percentage %d, and x. Okay, it is asked the user to input the number of the data to be stored and stored in it in the variable x. Okay, ask the user to input the numbers of data to be stored and stored in the variable x. Okay, next for I0, I less than x, I plus plus. This loop is used to input the data from the user. And this is display a prompt for the user to enter data for each iteration. Next. Okay. Oh, no. Scanf. It is to read the data entered by the user and store it in the numbers array at index I. Okay. Read the data entered by user and store it in the numbers array at index I. Next, this is loop perform the insertion sort process on the input data, and then it is for store the current value in the temp variable. It is for initial the variable g, the g variable with the value of the I. Okay. And then while this loop iterates as long as g is greater than 0 and the value of the temp is less than value at index j min 1 in the numbers array. Okay, and then we save large value to the right. Okay, save large value to the right, and this for decrease the value of g to continue checking the previous element. Okay, and then it is display a message indicating that the sort result will be shown. Okay, this is sorry. Okay, this is insert the value of the temp into the correct position in the already sorted list, but this is display a message indicating that the sort result will be shown. Okay, and this loop display the sort the result, and printf it is the display the value of the numbers array after the sorting the process. It is a insertion sort ascending program, but in the descending condition or DC, to sort in descending order, you will need to modify the comparison to check if the temp is bigger, greater, yes, the bigger than numbers g min 1. It means the element needs to be inserted at this position to maintain the descending order. Okay. The loop that shifts element to the right until the correct position is found. Okay, I think enough. Thank you guys. Bye.
Next, I will explain about bubble chart. What is a bubble chart? The working principle of bubble chart is to compare a data or data to I with data next to it or data to I plus 1. Exchange the two data if the data is greater than the data next to it or ascending sorting. Okay, now let's see an example of using the bubble chart method. Compare the first data with the second data. Because 5 is greater than 3, then exchange the two data, followed by comparing the first and second data. Because 5 is smaller than 7, there is no exchange, and so on until the data to n or 6. And then compare the first data with the second data, then the second data with the third data, and so until the data to n-1. Repeat the process until the data is sorted. Okay, this is the bubble sort algorithm. The first step is input the data, and then in line 14 until 21 is the bubble sort algorithm. And in the bubble sort algorithm is using 2-4. The first 4 is to repeat the data as much as data has been input. And the second 4 is to exchange the data. The data will exchange in condition if the first data is bigger than the second data. Okay, and if the data has been short, the program will show the result. Now let's try to running the program. Okay, a lot of data, 5, data 1, 3, 4, 1, 9, and 6. Okay, the result is 1, 3, 4, 6, and 9.